All right, so I'm back. I know my mistake, silliness. That when I plug -7 in, this gives me a negative answer, negative. So that's negative 343 subtract 2. This should have been negative 345. And when you go subtract a negative, that should have been plus 345. Subtract 2, and you get positive 343. This is a sum of cubes. That just means that this should have been positive 343. It's now about making the mistake, seeing where you made the mistake. Now it does work out, and don't just pretend, oh, it's almost right, so that's good enough. Know that if it's not right, go back, figure it out, like I try to do. So we have x plus 7. That comes from this. What's left over is x squared, subtract 7x plus 49. And then in the denominator is x plus 7. This is the work we did for polynomials and rationals at the beginning of the school year. Then notice x plus 7 divides out. So there's a whole divided out. So we have the limit as x approaches -7 of x squared subtract 7x plus 49. So now we're going to plug -7 in. Lord help me here. So 49 plus 49 plus 49. What does that give me? That's 49 times 3. That's 147. I'm feeling better about it. All right, let's try it one more time with limits. Walking through the mud here, we can do this. The derivative at -1 of this is the limit as x approaches -1 of f at x subtract f at -1. Let's make sure I did this one right. So plug in -1. You get -2 over 2. And -2 divided by 2 is -1. So we have a negative and a -1. Be careful of the signs, right? Just like here, subtract -1. So here, the limit as x approaches -1, we have 2x over x plus 3 plus 1. Well, that's easy to make common denominators 1. So I just took the denominator over itself. That's 1, but it has common denominators, and this is x plus 1. Then it's the limit as x approaches -1. And I'm going to combine like terms here. So 2x plus x is 3x plus 3 over x plus 3 over x plus 1. We're almost there. Now it's the limit as x approaches -1. I want you to notice we're going to go times the reciprocal of the denominator. Now 3x plus 3, the 3 can be factored out. And then times the reciprocal of the denominator, you can now see the whole will divide out. Now you can plug in -1. And you get 3 over. Now -1 plus 3 is 2. So it's 3 over 2. And that's the derivative at that point. Man, long way. You got to know it. That's the origins of the derivative, limit. But then we have shortcuts we use because that will be painful to do forever and ever and ever. So how about some shortcuts? Can we just quickly use some shortcuts to do the same thing and not have to use half a page to get the answer for the derivative? So how do you find the derivative using the power rule? And if it's not a power, make it a power. 4 times 5, 20, x cubed. That's the rule. You multiply and then subtract 1 to the exponent. The derivative, x squared, 2 times 1, subtract 1 to the exponent. -5x is -5. And the derivative of 14, 0. Keep going. That's how simple it is. Don't make it complicated. 3 times -4. Subtract 1 to the exponent. 2 times 1. Subtract 1 to the exponent. 1, -9x is just -9. And 35 is 0. 7, we need to make this calculus friendly. That's 3x to the 1/2 plus 1. So that when I take the derivative, it's 1/2 times 1 in front. Subtract 1 from the exponent. So 1/2 take away 1. That's -1/2. And this actually has another rule that we need to have in there, and it's not a rule that's brought up. So I think the example didn't realize that this is another rule called the chain rule. And the chain rule is you do the power rule, but if the base you can take the derivative of and it's not 1, that must be included. So the derivative of 3x is times 3. So this is called the chain rule, which is a rule we'll come up with later. So we do the power rule and then take the derivative of the base, which is 3. That needs to be included. This is called the hook for the chain, that we need to remember the hook. Now, if the derivative of the base is 1, then we don't need that hook. But if it's something other than 1, the derivative, then we need the hook. So let's try this one. So first of all, calculus friendly. How do I write that as a fractional exponent? 7 is the numerator and 3 is the denominator. Take the derivative of this. 7 over 3 times 1. And then, remember my thing? Subtract 1. So that's like 7 take away 3. So when you subtract 1, you get 4/3. Again, can you write this calculus friendly? That's to the 1/4. And then recognize that you can actually combine these together using an algebra rule. You could also use the product rule. But if you multiplying the bases are the same, just add the exponents. That's 5 over 4. So because I can do some simple algebra, now take the derivative using the power rule. So that's 5 over 4x. Subtract 1. So 5 take away 4, and that gives you 1/4. 5 take away 4 is 1 over the common denominator. 10. Can we write this? Calculus friendly. The first one's fine, but the second one needs to be written as 6x to the -1. Now it's calculus friendly where I can do the power rule. The derivative of this, 2 times -4. Subtract 1 from the exponent. -1 times 6. Subtract 1 from the exponent. Number 11. Make this calculus friendly. That would be x plus 2 to the -1. Now do the power rule. So the power rule will be -1 times 1. Subtract 1, which would be -2. If you think this could be a chain rule, there might be a hook. Well, what's the derivative of the base? And the derivative is just 1. So I don't need to go times 1 at the end. So the hook doesn't change anything. So that's exactly the answer. All right, one more like that, number 12. Can I make this calculus friendly? So when I see a monomial in the denominator, that means one term, I can separate this into 2 fractions. That's a good algebra technique. And then simplify each one. So x squared over x cubed. Subtract, and I get x to the -1. Here, do the same thing. The 4 is there, but subtract, and 1 take away 3 is x to the -2. So do some basic algebra, some exponent rules. Now we just have powers. Now I can do the power rule. -1 times 1 is negative into the -2. -2 times -4 is plus 8. And then subtract 1, and it's perfect. How about using the other 2 rules we came up with this lesson, the product and the quotient rule? No simplifying. So the product rule is the first, x cubed plus 1 times the derivative of the second. 2 times 4, 8x. The derivative of -5 is 0. Then the second, 4x squared subtract 5 times the derivative of the first, 3x squared. Done. Let's do it again. The first times the derivative of the second, plus the second times the derivative of the first. Now, the derivative of 1 is 0, and the derivative of -3x is just -3. Done. And I don't expect you're simplifying this. 15. Now we're going to do the quotient rule. So for the quotient rule, we're going to draw a healthy fraction line. And it's the bottom times the derivative of the top. X squared, 2 times 1, that's 2x. The derivative of 2 is 0. Subtract the top times the derivative of the bottom. Now we don't need a 1, but I'm putting it there just because. So the derivative of x, 1x, is 1, and the derivative of negative 3 is 0. Then take whatever in the bottom, put parentheses around it, and square it. That's the rule. You don't want to do limits when you don't have to. Take forever. Take the rule and use the rule. 16. Again, the quotient rule. That is the bottom times the derivative of the top. So x squared is 2x, and negative 3x is negative 3, and negative 7 is 0. Subtract the top times the derivative of the bottom. That's 2x. I don't need the 0 at the end. And then take whatever is in the denominator and square it. And that's it. I know this took 3 parts, and there's all kinds of different reasons, but we got to the end of the lesson. Mr. G Math, over and out. I'm so proud of you. This is big, big, big time calculus, and you're doing it. I'm so proud of you. Until next time.